So good morning. Thank you, Phil, for giving me the opportunity to speak today about this literature on the physical activity as a potential preventative behavioral activity that people can do against Alzheimer's disease. And before I start, I want to talk a little bit about Alzheimer's disease. When I speak to groups that are this distinguished and senior, usually as soon as I mention Alzheimer's disease, people start self-reflecting and thinking, oh my gosh, do I have Alzheimer's disease? So I want to just hopefully allay your fears so that you can focus on what I'm talking about today by telling you that it's perfectly normal if you can't remember where you put your room key. When you need to be concerned is if you have the room key but you can't remember what to use it for. All right? It's also perfectly normal if you see someone only occasionally, maybe at a meeting once a year or something like that, you can't remember his or her name. But you need to be concerned if you can't remember the names of your own children. Okay? So hopefully everybody's with me and you're not concerned from a personal standpoint. From a public health standpoint, obviously Alzheimer's disease is something that we need to be very concerned about. The worldwide prevalence in 2013 is estimated to be about 44 million. But what's even scarier really is to think about the predictions with regards to prevalence. We expect that by 2030 about 65 million people may have Alzheimer's worldwide. And what to me is really frightening is in the 20 years subsequent to that, it's predicted that that number will actually double to 107 million people. Further, we know that current treatments really don't offer any kind of a cure for the disease. The treatments that we have really only treat the symptoms and help to mitigate some of those. And so obviously the research that's ongoing is focused on preventative strategies that might postpone the people getting Alzheimer's disease. So physical activity is obviously what I want to talk about as a behavioral strategy that holds promise as a preventative treatment for dementia. And one of the real challenges in this area is that it's very hard to use randomized controlled trials with Alzheimer's disease or dementia as an endpoint because of the time until diagnosis, and also, of course, because of the relatively small percentage of people who actually get Alzheimer's or dementia. You'd have to have huge trials and follow people for many, many years, so it's hard to have RCTs in this area. So what I want to talk about today is the evidence that I think suggests that physical activity holds promise, which comes from RCTs with cognitively intact individuals, comes from RCTs with cognitively impaired individuals, also comes from evidence from epidemiological studies where they do follow large numbers of people for long periods of time, but obviously haven't manipulated physical activity. And then at the end, I want to talk a little bit about moderators, which will tie in really nicely with the other talks that we've heard at the conference. So if we look at the evidence with cognitively intact, in 1997, I did the first meta-analysis in this area, and it was a really broad review. I was looking at chronic exercise, acute exercise, all across the spectrum, had 134 studies. But one of the things that I did was that I pulled out the studies that had used RCTs, and at that time there weren't that many, so I just did it across all ages. And what I found was that there was a small effect, positive effect for physical activity on cognitive performance. Also, when I looked at just the chronic exercise studies, age was a significant moderator, and what's interesting is that you actually got the largest benefit for people who are middle-aged, 45 to 60, and then you still got a small, statistically significant positive effect for people who are 60 to 90 years of age. Colcom and Kramer in 2003, being so much smarter than me, limited their meta-analysis to 18 studies. That's so much better than 134. And they focused just on older adults. And what they found was that the overall effect size was moderate, almost half a standard deviation. And importantly, they also pointed out that the effect sizes really differed depending on the cognitive domain that we were looking at. So they reported range from 0.27 to 0.68, with the largest effects, as many of you may know, being observed in measures of executive function. Angavaran et al. In 2008 had 11 RCTs in their review, also focused on older adults. They didn't report an overall effect size, but they reported a very similar range of effects to what Colcom and Kramer had reported. And they also noted that it depended on the task that was used and on the particular comparison group. So do you use a no treatment control, or was it a stretching and flexibility type of control group? So overall, if we look at the evidence with cognitively intact, I think it's pretty clear that physical activity benefits cognitive performance, and the effects tend to be in the small to moderate range. Now, the other group of studies I want to talk about, or another group, is the evidence with cognitively intact but using epidemiological designs. And so here we've got, of course, retrospective studies where at first contact they measure cognition, and then they go back in time and ask retrospectively about physical activity. Then we also have case control and prospective cohort studies where at first contact they measure physical activity in some way, and then they follow them forward into the future and measure some sort of a cognitive outcome, either a clinical cognitive measure like diagnosis with Alzheimer's disease, or cognitive performance on like a mini mental status exam or something of that nature. This literature has also been reviewed meta-analytically on a few occasions, and just to sort of orient you to this, so there were 3 reviews that were conducted. Daviglus's review focused just on Alzheimer's disease as the endpoint. Hamer and Chida's reviews, they sort of did 2 separate reviews within their paper. They did one group of 80 studies with Alzheimer's as an outcome and another with dementia more broadly defined. And then in the Sophie et al. Review, they used just cognitive decline as their outcome measure. And so to basically give this in a real quick overview, of course, the lowest PA is shown in the blue bar. And so that's always the referent group, always given the odds ratio of 1.0. And so what you see right away is that regardless of the review that was conducted, regardless of the cognitive outcomes that were used, we see that physical activity is protective against those sorts of cognitive decline, and on the order of like a 28% reduction in the Daviglus down to as much as a 45% reduction in the Hamer and Chida review. And you may also notice as well that this is for 10-ish studies in each of the reviews, but thousands, tens of thousands of participants in these reviews. Okay, so now let me tell you a little bit about the RCTs with people who are already cognitively impaired. And there have been 3 very recent reviews done of this literature, and I want to kind of orient you to these reviews before telling you what the findings are. If you look at the bottom, it shows, I don't know what you call that thing, a bar graph, right? Trying to sort of show where the overlap is in the studies that were included in these reviews. And so if you'll notice, the blue bar shows that there were 6 studies that were included in all 3 reviews. The kind of, I don't know what color that is, the mauve-ish color shows that there was 1 study shared between Wang and Oman. The green bar shows that there was 1 study shared between Oman and Gates. But what's most important is that there are an additional 7 studies in the Gates et al. Review that were only in that review, and that'll be important when I talk to you about the results in just a minute. So the Wang et al. Review, they were actually incredibly enthusiastic when they reviewed the literature, and they said that overall we find a positive effect of physical activity and cognition in persons with mild cognitive impairment that's the size of about a quarter of a standard deviation. The Oman et al. Review was a systematic review, and so they didn't calculate an overall effect size, but they said they were also very enthusiastic. They said there were promising effects for global function. 60% of the results were positive. For executive function, 50%, and for attention, 100%. And then what's really interesting and different is that in contrast to those 2 reviews that were very optimistic, the Gates et al. Review was very pessimistic. In their review, they focused on the fact that 92% of their results were non-significant, and then they concluded that there were really negligible effects for these various cognitive domains that are really relevant to Alzheimer's disease, executive function, memory, and information processing. So in putting this talk together, I was trying to really think, well, how does this make any sense? And one of the things I thought it made sense to look at was the nature of the exercise that we used in the studies included in the reviews. And so if you just focus on the blue bar, which is the studies that was in all 3, what you see is that I think you could argue that all of these studies were aerobic in nature. So the blue part of the pie chart shows you the ones that were truly just aerobic, like a walking program. The red is a Tai Chi, and then the yellow is a mixture, but it had an emphasis on aerobic. So it was walking, but we also did stretching like that. By contrast, if you look at those additional 7 studies that are in the Gates et al. Study, you still see some aerobic, you still see some mixed with aerobic, but now what you have is about a third of the studies actually having no aerobic component whatsoever. And so most of those studies tended to be focused on strength and balance, and so cognitive outcomes weren't necessarily the primary outcome, so the studies were designed differently. So that's one possible explanation for why the conclusions that were drawn were so very different. There's also 2 reviews that have been done where they focused on studies that have looked at people who are already clinically diagnosed as having dementia and whether or not physical activity can still benefit these individuals. Again, you see here an interesting phenomenon where 8 studies were shared between the 2 studies, but then each of these had an additional 6 studies that were unique to their review. despite the fact that in this case there is a lot more variability really in the studies that were concluded, the conclusions were still very promising and very optimistic. So Oman et al. Said that for global function there were 5 of 8 positive effects. That percentage I can't do in my head. For executive function there were 75% positive effects, and for attention it was 100%. And Forbes et al. Was a meta-analysis, and so they concluded that there was an overall average effect size of about half a standard deviation. So much more promising conclusions, but then to be fair, I thought, well, let me tell you about what the studies looked like. In the Oman et al. Studies, they do now include some studies that don't have an aerobic component. And in the Forbes et al. Study, they have almost a third of the studies that don't have an aerobic component. So maybe I'm wrong. Maybe it wasn't the nature of the exercise that explains the differences that we see the MCI. Or I think another possibility is that with folks who already have dementia, because they're even additionally less fit, perhaps these interventions that didn't focus on aerobic were nonetheless more aerobic than they had been in, with healthy normals or with MCI patients. So in summary, in cognitively normal adults, the results from the RCT support that physical activity actually is a causal agent and results in cognitive improvements with small to moderate effects. Epidemiological studies also support that physical activity is protective with reductions in risk of 28 to 45%. And then in cognitively impaired older adults, RCTs again show that physical activity can be a causal agent protecting against cognitive decline. And to summarize this literature, it's more clear on global measures of cognition than it is in particular cognitive domains. So what I want to talk about next is the idea of moderators and who benefits the most. And it ties in great with the talk that we heard yesterday. There is a gene called apolipoprotein E, which is a risk factor for Alzheimer's disease. It's predictive of late cognitive decline, and it's also predictive of the familial form of Alzheimer's disease. And so just to orient you to this genotype just a little bit, if we look sort of at the bottom here, we get, for those of you who don't know as much about genetics, we get one allele from each of our biological parents, right? So we could be E3, get one from a biological mother or father, E3. And if we're E3, E3, that occurs in about 55% of North Americans of European descent. We have about a 3% risk of having Alzheimer's disease by the time we're 80, and the typical age of onset is about 73. The E4 allele is sort of the bad allele. Well, it is the bad allele. And so if you have one copy of the E4 allele, your risk of Alzheimer's goes up to about 8%, and the age of onset is a year earlier. That occurs in about a fourth of the population. The group that we're obviously most concerned with is the group that gets 2 copies of the E4, one from each parent. They're called homozygous for the E4 allele. Only occurs in about 2% of the population, but now the chance of having Alzheimer's disease is 50% by the time you're 80, and the age of onset is 5 years earlier, which is in itself important because that suggests that these individuals may be living longer with the disease. So there are a number of studies that have looked at the potential of ApoE to actually moderate the relationship between physical activity and cognitive performance. And I'll talk about these in 2 groups, the correlational studies and the prospective studies. In 2007, we published some work in which we had looked at 57 cognitively normal women. And we measured a lot of different measures of cognition, but the only ones where there was a significant interactive effect were these 4 measures. That's okay because these are the 4 measures that were really the primary outcomes. They're measures of memory and attention. The results for all of them were very similar, so I'll just show you an example from one. Across the bottom axis there is centered VO2 max, so the further to the right you are, the more fit you are. Across the y-axis is performance on the cognitive task, with the higher score being better. And what we found was that for the legend is showing you how many copies of the E4 allele they have. So for the non-carriers, the zeros, and the people who are heterozygous, they had 1 copy of the E4 allele. There was essentially no relationship between physical activity, or excuse me, in this case, fitness, and cognitive performance. But for the people who have 2 copies of the E4 allele, there's a strong positive relationship, and it explains about 33% of the variance. Dini et al. In 2008 did sort of a similar study. They used men and women. They were also cognitively normal. And they measured reaction time on a working memory task, and then they measured physical activity instead of fitness. And let me orient you to this because I'm going to use the same layout for the subsequent slides. So on the left is always going to be the carriers, and on the right is always going to be the non-carriers. And so if we can work sort of backwards from right to left with this slide. If you look at the slide on the right, for the non-carriers, there's essentially no relationship between physical activity and cognitive performance. if you look at the figure on the left, for the E4 carriers, there is a significant relationship, and in this case, it's reaction time on the y-axis, so it's showing that as you're more physically active, your reaction time is quicker, so your cognitive performance is better. So interim summary, both of these correlational studies are showing the same thing. ApoE moderates the effects, and where we see the strongest relationship between either physical activity or fitness and cognitive performance is for the carriers. Okay. Prospective studies, there are 6 of these that I'm going to go through pretty quickly, so I won't linger on the details. Schwitt et al. Focused on men. They used a 3-year follow-up, and they looked at scores on the mini-mental status exam. And what they found, and again, this will be the same layout on every graph that I show, carriers on the left, non-carriers on the right. The carriers are also in red because that's the group that's at highest risk for Alzheimer's. Okay? And what you see when you look at this is that the only place that physical activity makes a huge difference is for the carriers. So their reduction in risk from one, well, in this case, it's a hazard ratio. So if the active group has a risk of 1, the non-active ApoE carriers, the sedentary ones, have a risk that's 3.5 times as great of having Alzheimer's disease. Rovio et al. Used men and women. They used a much longer follow-up period, and here they were looking at Alzheimer's disease as the outcome. But very similar findings, right? So where we're seeing the effect is for the carriers. Kivipelto et al., again, men and women, a long follow-up, 21 years, Alzheimer's disease as the outcome. Similar finding, right? The biggest effect you're seeing is for the carriers. And Needy et al., again, men and women. This is back to using a shorter follow-up and using the MMSE as the measure, but very similar findings. This one looks a little bit different because, I can't show this to both sides at once, because the rightmost, the green, the carriers, I don't know how to say it. They didn't keep one referent group for all 3 comparisons. They used 2 referent groups. So that's why it looks a little bit different. But if you just focus on the difference between the active and inactive, you'll see that you're only seeing a big difference for the carriers, not the non-carriers. So if that was the only literature, like I'd be done and I'd be happy and we'd be thinking this is clear as it could possibly be. Problem is there are 2 additional prospective studies out there that show the exact opposite finding. Tolpanen et al. Show that the only place they get a significant effect of physical activity is for the non-carriers. Those green bars are showing sort of a dose-response effect for physical activity for the non-carriers. And then Podewils et al., the biggest study that we have in this area, also shows that the only place they get a significant difference is for the non-carriers. It's harder to see on this because it's a little bit more complicated design. But the only place they report a significant difference is for the non-carriers. So it would have been beautiful. I'd have been thrilled. But to show it to you in summary, you know, the blue circles are kind of showing you where we get the biggest bang for our buck. And in 4 of the studies at the top, it's with the carriers. But on the 2 at the bottom, it's with the non-carriers. So it's not as clear as we would like. So what is clear is that ApoE seems to moderate the effect. Everybody found that in their studies. But what's not clear is for which group does physical activity make the biggest difference. Most of the literature supports that the larger effects are for the carriers than the non-carriers. That was true for both correlational studies and for 4 of the 6 prospective studies. And so what I really think we need to do is to move towards research where we actually use RCTs that we can look at whether or not ApoE moderates the effects of physical activity on cognitive performance. We've very recently completed a study called the PAD study, Physical Activity in Alzheimer's Disease, where we did an 8-month intervention with older, cognitively normal adults who have a family history of Alzheimer's disease. The family history of Alzheimer's disease is important because that should help us, did help us, get a larger percentage of people who are E4 carriers. And so what we're going to be finding out in the very near future is whether or not there was a difference, whether or not the cognitive gains that occurred over 8 months differed as a function of ApoE status. And so that's a direction that I think the research needs to move into. So I don't think physical activity cures Alzheimer's disease, but it could be very important as a preventative. And Barnes and Yaffe wrote a recent paper that really talks to us about and shows us some data that would show how important it would be to change physical activity if it has an impact on Alzheimer's disease. And based on their findings, they show that if we could reduce physical inactivity by 10%, that would decrease the number of cases in the United States by 90,000 and in the world by almost 400,000. If we could reduce physical inactivity by 25%, obviously you have even a larger impact. And this is so important because, as you all know, this is where I'm preaching to the choir, right? Physical activity is low cost, relatively few negative side effects, but also has a host of associated mental and physical health benefits. So the total benefit is really high. Just to show this one other way, the Barnes and Yaffe work, physical inactivity, relative to all the other things that we might change, according to their data, we would get the biggest benefit from making changes in physical inactivity. And future directions, I saw Carl stand up, so I'll be really quick. I think it's really important for us to explore combined interventions. Diet and exercise, that literature hasn't actually been very exciting. The results have been somewhat disappointing. But cognitive training and exercise, those results are much more promising. A recent review of 8 RCTs showed positive effects for 2 out of 3 studies with cognitively healthy and 4 out of 5 with cognitively impaired. It's important to continue to explore moderators, not only the ApoE gene, but there's also some research looking at BD and F genotypes, and to look at mechanisms. People are looking at brain-derived neurotrophic factor, cerebral structure, cerebral function. And then the last thing that I'll say is, as I was sort of thinking about this, I was doing what I always do and what every reviewer does, which is to say, we don't have enough well-designed RCTs. And I was thinking, that's kind of unfair because it suggests that we, the researchers, don't know what we're doing and can't do a well-designed RCT. But I was thinking, that's not really the issue. The issue is there's not enough funding being directed towards exercise, in my opinion. When I look at RFAs for cognition, exercise is very rarely mentioned. If it is mentioned and we apply, you look at the review panels, oftentimes there's not a single person with a kinesiology background on the review panel. And sometimes when we receive reviews, in my experience, sometimes I get reviews that suggest that the reviewers don't have any knowledge of our field or any appreciation for the value of exercise. So I'll stop there and thank you again.